Let's get this screen shared. And um, just so you know, we are going through the practice test to answer any questions that people have on any of the problems there in preparation for what we're about to do. Just take the real test. Yeah.
Has anybody actually a live viewing of the?
It's not my intention that people will actually show up to a live viewing of this. The only reason I do this is to have a recording that people can watch. I could probably just as easily do it with, I don't know, whatever whatever magic camera stuff they've got going on in this room here, but this is what I know from my years through COVID, where we all learned how to teach all over again. So, yeah, I like this problem because it's much like some of the problems that you're going to see in the okay. And in fact, let me do something here so that I can, yeah, so that I can write on this. What that? Yeah. Mhm. Okay, so I'll do this so that people on Zoom can see what I'm doing as well. Okay. Okay. So you've got two teams. This kind of reminds me of the World Series. For first place, they play games. They keep playing until one of the teams wins three games. So a little different than the World Series. They have to win how many games in order to win the World Series? Mr. Rocky's jersey? Four. Yes, you have to win four games. And so, what's the maximum number of games that you can play in the World Series before somebody eventually is going to get four games won? Seven. Yeah, yeah. Because the most you can draw it out is to have one team win three, and then for the other team to also win three, and then that last game finally decides who's the winner, right? Oh, did we really? Oh, okay. They went all seven games. What was the World Series between this year? Oh, the NBA Finals. Okay. Okay. How many do you have to win there? Four? Okay. Very, very cool. So if you think about it, okay, if you're playing games back and forth and you go until somebody wins four games, a total of four games, how long can that get stretched out for? How much can that get stretched out for? So yeah, you're going to have at least four games, right, for one side to win. But how many more games could also you have to play before somebody gets four? So, for example, if Team X wins the first one, Team Y wins this, then X and Y, then X, then Y. Has anybody won four times yet? What's going to happen in the next game? Somebody's going to get four games won. And whichever it is decides it. So that's a total of 1, 2, 3, 4, 5, 6, 7 games. So that's as long as this can get drawn out. If there are four games to win. What is it for this game? This turn is just three. Okay, so how bad can bad get? How much can we draw that out? Five. Yeah, yeah. So
That's wrong.
oh yeah, the poor Rockies. Okay. For the first place, they play games to keep playing until one of the teams wins three games. No tie is possible. Okay. In each game, Team A has a probability of 0.85 to win the game. So Team A winning has a probability of 0.85. So what's the probability that Team B wins? 0.15. Yeah, because these two probabilities should add up to one. Yeah, they're complementary. Find the probability that Team A wins the championship. Okay, so this gets kind of hairy here. So we've got game one. What's the probability that A wins? 0.85. What's the probability that B wins? 0.15. Okay. We're going to have a game two, aren't we? So these branch out here. Game two. Probability that A wins, that's again 0.85. Probability that B wins. Okay. Well, that's A, and that's B. And then we'll definitely have a game three. And this is 0.85, 0.15, 0.85, 0.15, 0.85, 0.15, 0.85, 0.15. Okay. Game four. Take a look at the possibility on top. Will there be a game four? No, because in this case, A1, 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 series is over. Yeah. Okay. So this pathway has ended. For this pathway, we have two possibilities still. For as is the case for all these other ones here. So we keep going, we keep going, we keep going, we keep going. So this problem is actually pretty extensive, isn't it? Okay, so we keep doing this. And also this bottom one here. Do we have a fourth game on the bottom? No, we don't, because B has won 3 times. So I'm actually going to erase this bottom split here. Okay, so that's A, B, A, B, A, B, A, B, A, and B, with 85s and 15s going all the way down here. Tell me about this possibility here on top. Do we have to play another game or is the series over? It's over. Yeah. This one below it, though, we've got 2 wins on either side. We have to play one more game to see who won. Let's see here. A, B, A, A, that's the end. A, B, B, I'm sorry, A, B, A, B, we have to play one more game to see who wins, and so on and so on. And so, how do I find out the probability for each one of these branches? A and A and A. What do I do with these 3.85s? Multiply, not add them, multiply them. So when it's and this and this and this, that's multiplying. Okay, so I'm going to have 0.85 times 0.85 times 0.85, and that'll give me the probability that of this top one taking place. Actually, if somebody can find that out for me, that'd be helpful. 0.6141. So there's a 61% chance that what's going to happen? Yeah, that it's a quick sweep. Team A is, with their 85% chance of winning, they just win the first 3 games and it's over. 61% chance that that's going to happen. Okay, so there's also a possibility that the first one, Team A wins, second one, Team A wins, third one, Team B wins, fourth one, Team A wins. What's the probability for that? Well, it's 0.85 times 0.85 times 0.15 times 0.85. And that's going to be okay, good. And then this next one here, A, B, B, A, that's 0.85 times 0.85 times 0.15 times 0.8 times 0.15 times 0.85, 0.0138. So there's only a 1% chance of that happening. Let's do 0.85 times 0.85 times 0.15 times 0.15 times 0.15. That should be even less probability. It's a little messy, and so it gets a little. But do you see how each possibility branches off like that? The grouping. So I'm just following each branch as far as it goes. Yeah, well, I'm going to branch down here now. B, I have to branch some more. This will be A. So this will be A, B, A. So this is the instance. Team A wins games 1 and 2. Team B wins game 3. Team A wins game 4. If we multiply those numbers together, we get 0.0924. And in this case, this is A winning, and this is A also winning. For the next one here, do B, we've done this branch, B, A, and that's that probability. And which side wins here? A wins. The next one is B, B, B. There are 3 B's here. B wins on this one. Okay. And then we just keep going here. So it's unfortunate I don't have really enough room to be able to do this justice. But I think if I spread it out a little bit more, maybe if I do this on the board here, it'll be easier to see. Might be a little easier to do this without the numbers too. I'm just going to show A, B. So that's game 1. Game 2. A, B, A, B. All right, game 3. Okay, so this is either A, B, A, B, A, B, A, B. It might be a little easier to read here. So A wins, A wins, A wins. We're done, right? Okay, so that one's finished. So that's an A. That's an A win there. And what's the probability of that happening? It's 0.85 times 0.85 times 0.85. So we could list that here. I think that was 0.61. What was it? 614. Thank you. So that's the probability of that event happening. Then we have oh, let's go down now. B, we haven't gotten a winner yet. We need to play a 4th game. And either A or B is going to win that game. If A wins that game, they win the tournament. We have a specific probability for that. That was 0.0924. The next one down. What's the next one going to be? A, B, B. Nobody's won yet. We got to do one more game. Yeah, the next one, A wins. And I think that was 0.0138 after we multiply 0.85 times 0.85 times 0.15 times 0.15 times 0.85. Okay, this bottom event here, B wins because it's B, so 0.85 times 0.85 times 0.15 times 0.15 times 0.15. That is 0.25% possibility there for that. And we just basically do this same procedure all the way down. So we've got 3 different events here on top in which A wins. is it possible for more than one of these things to happen? Or is it an either or? What's that?
I think it's for you first.
Is it possible for Team A to win 3 times and also for Team A to win the first 2 times, but then lose the next one, but then win the fourth one? Can both of those things happen, or is it an either or? Either or, yeah. So if I want to ask, what's the probability that this happens, or this happens, or this happens? What do I do with these numbers? And it's the very simple addition formula where I don't have to worry about things overlapping, since they're mutually exclusive events. They can't all happen at the same time. So yeah, these 3 will add together along with all the other instances down here, which A wins. It will tell us the total probability that A wins. Right.
So to find the A wins, we have to go finish everything, right?
Yeah, yeah. Actually, what you could do is you could ignore all the ones in which B wins, because once you find the probability that A wins, how can you find the probability that B wins the turn? Subtract from 1. Okay, so you only have to do it for one side here. So yeah, that's as complex as these problems get.
There's a simpler way to do this.
Yes, the binomial
That's what
equation. Okay, so you Googled that. I'm actually planning on giving you some more information along those lines here for that. I can tell you that the problems on the tests that are like this are not this extensive. Yeah. What other things do we want to go through? But make sure you know how to do this tree diagram kind of thing here.
Okay.
First one, yeah. Let's look at that here.
I had to go back to 3rd grade and figure out what a continent was.
A consonant? Yeah. Anything that's not A, E, I, or U. I always love that. This is why I like mathematics, because everything was like cut and dry. When I remember the vowels were A, E, I, O, U, and sometimes Y. I was like, sometimes when? Sometimes. Oh, okay. Sometimes Y, because sometimes Y acts like a vowel, like in candy, it has an E sound, and sometimes it acts like a consonant, like in youth, it has a Y sound, so that's a consonant. So anyway, that's what they meant by sometimes. So all right. If you randomly select a letter from the phrase Robert likes to eat tacos at Chipotle, what is the probability that you select a consonant? In other words, something other than A, E, I, O, or U. Well, if you're randomly selecting a letter from this phrase, how many possibilities are there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 7. I've got 31. Did others get that too? Okay. And you know what? Let's just make it easier and let's do vowels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 out of 31 for vowels. So what is it for consonants? 13 out of 31 vowels. What's 31 minus 13? Is it 18? Yeah. So for consonants, it's 18 out of 31. Oh, what? That sure looks right. Oh, it doesn't like the equal sign. I'm used to putting things into Excel or into Google Sheets where I start with an equal sign. Okay. What's that?
There's 31 consonants. No, there's just 31 letters in that phrase there.
So like if you count all the letters in that phrase, there's 31 letters and 18 consonants.
18 of them are consonants and 13 of them are vowels. Did that clear it up for you, Todd? Oh, consonants and vowels? Yeah, so vowel is sometimes Y. Fortunately, there's no Y in any of these words here, so yeah. That works well. Yeah. So other questions here. So it sounds like you understand the concepts here, Todd. It's just this vocabulary word, vowel and consonant. I mean, it's the same kind of thing here for these. Probability that the student did not get an A. Well, how many students were there total? 72. How many of them did not get an A? Well, that's the B's and C's, right? So we add these together. That's 42. So 42 out of 72. If you divide that out on your calculator, you get that. Okay, so that's the kind of thing that we've got here. Either way is going to work. Dividing it by the total number of, yeah, just like we did with the vowels and consonants. Yeah. Student was male and got a B. How many of those? 9. Yeah, so that's 9 out of 72, or 1/8, as it turns out. Probability that the student was a male or got a B. Yeah, is it 50? Yeah, because how many males are there? There's 40. Or got a B. So how many are we how many more do we need to add to that?
60.
Yeah, 24 and take away 9. Or just add the 15 here. It might be a little easier. Let me try to show this using the annotation here. So male, okay, so that's these 3, right? Male A's, male B's, male C's. Or got a B. Well, who are we missing here? The 15, yeah. Okay, so it's this plus this plus this plus this, all of that divided by 72, right? You could also use this. Okay. Probability of A, that's male. Probability of male is 40 over 72, plus probability that they got a B, that's 24 out of 72. Everybody see that? Minus male B's, that's 9 out of 72. You'll get the same answer if you do that. All right, let me saw that. Scroll down. Student got an A given that they are male. You definitely want to use your formula for this. Got an A given that they are male. So I'm going to say A given that they are male. There's a formula for this. Probability A and male divided by the probability that they're male. Okay, so A and male, that's 17 out of 72. And probability that they're male, well, that's 40 out of 72. And how can I simplify this fraction here? What? Yeah, but I mean, effectively, I can multiply top and bottom by 72. What's going to happen up here? If you're not clear, Yeah, these things will cancel in here. I'll just have the 17. Same thing will happen down here. I just have the 40. So there we are there. All righty. Letters in the word mathematics are arranged randomly. What's the probability that the first letter is E? Well, how many possibilities are there for the first letter? One.
You only have.
No, but
If I'm messing these letters up, how many possibilities are there for the first one? Yeah, there's 11 possibilities, right? How many of those possibilities are E? Just one. So the probability is 1/11. Okay. What's the probability that it's M? 2/11. Yeah, good. Seeing that? Again, there's 11 possibilities, but two of them, there are two M's in mathematics. And so, all right, die is rolled twice. What's the probability of showing a 5 on the first roll and an even number on the second roll? All right, yeah, a 5 on the first roll, that's 1/6. And what have I got to do? Multiply an even number on the second roll. Yeah, that's 1/2, isn't it? Are we clear on that? On why it's 1/2? Yeah. Okay. What's the answer? 1/12. Yeah. I can see your neurons firing there. Gabriella buys a bag of cookies that contains 5 chocolate chip cookies, 6 peanut butter cookies, 4 sugar cookies, and 5 oatmeal cookies. What's the probability that Gabriella randomly selects an oatmeal cookie from the bag, eats it, then randomly selects a peanut butter cookie? Okay, so I gotta draw this. I gotta do this in two parts here. Because are these two events independent of each other? They're not independent because since she's eaten the first cookie, that changes all the probabilities, doesn't it? Yeah. So uh randomly selects an oatmeal cookie. How many cookies total are there? Is it 20? Yeah, you're right. So it's 20 cookies overall. What's the probability that she selects an oatmeal cookie? 5 out of 20. Okay. Now she eats it. Now she's going to pull out a peanut butter cookie. Okay. How many cookies are there total now? 19. And how many of them are peanut butter? 6. There you are. Okay. And, you could think of this as being just a single branch on the tree diagram here. Okay. We're only having to analyze the one instance here where this is oatmeal and then peanut butter. So this will be 5/20ths and this will be 6/19ths. So multiplying those two things together, let me cancel some things out here. 15 over 190. Oh, I should have been able to. That's a 1 and a 2, isn't it? So 3 out of 38. How's that? Sehr gut. All righty. Any others we need to go over here? Make sure you've got all your formulas. Yep. Make sure you know how to do tree diagrams. All righty. Awesome. I'm going to pause the recording here for the next hour. You've got an hour to do the test here. How was that? Yeah, yeah, okay. Yeah, but having those graded uh, at the end of the afternoon here. Um, I wanted to cover this in a little bit more detail here. This is the binomial distribution that we were describing beforehand. If you recall, the binomial distribution is what we can use to ask the question, to ask the question, if so-and-so has got a batting average of 0.3 and that person is up to bat 5 times, what are the chances that this person's going to not have any hits, not have, have 1 hit, have 2 hits, have 3 hits, and so on. So it's actually a distribution because there's a list of possibilities, not just one. And so I've indicated to you, we kind of went through those kinds of problems, and I mentioned that you're going to have, you're going to be able to do these problems using your spreadsheet here as well. I just wanted to briefly show you how you could also reproduce a lot of these calculations. Now, I know in particular, this part of it looks a little crazy. It involves this thing here called the factorial. If you've ever wondered what that exclamation mark is on your calculator, it's called a factorial. So the pattern here is that 3 factorial is equal to 3 times 2 times 1. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. So so you can keep that in mind as you're doing this. Another way in which you can describe this is through this. This is actually a simpler way, in my opinion, to describe this. Come on. Okay, and I know that looks like a lot of gobbledygook there. You've got 4 variables that you're dealing with here. P and Q and N and X. 4 variables that you're working with here. Plus there's the C in there. What's that all about? P is the probability of success, the probability that so-and-so is going to get a hit when so-and-so is up to bat, the probability that when a person makes a shot on the goal, that's going to go in. You can make a lot of different things successes. But if I know that the probability of success is, let's say, 40%, then what's this probability of failure? Probability of success is 40%, then what's the probability of failure? 60%. Yeah, because these two things have to add up to 1, don't they? They have to add up to 100%. Okay. If he's up to bat 7 times, that's a lot of up to bats, by the way, for what's N? 7. Okay. And there's a number of different possibilities. No hits, 1 hit, 2 hits, 3 hits, 4 hits, 5 hits, 6 hits. The number of hits that we're talking about is X. Okay. So these are exponents here, P to the X, Q to the N minus X. And what in the world is this? This is called combinations. If you have your calculator handy or whatever calculator that you use, let me see. Let me look around the room and see the kinds of calculators that you've got here. On the TI calculators, the way that you do this is by using the PRB button. It's a button with letters PRB on it. And if you hit PRB, then you'll see a set of options there, 3 options. The second one should be NCR. Okay, you'll notice the third one is exclamation mark. We now know that that's factorial. By the way, see if you can use this to find out what 52 factorial is. 5, 2, and then PRB, choose 3 here.
Find the factorial?
Yeah, 52 factorial. So you type in 52 and you're going to hit PRB.
And then you select
And then-
the exclamation.
Yep, the exclamation mark. And
You do
then hit
equals?
enter and see what you get there.
Oh, it would be the equals.
Enter or equals or whatever it is. And you get some kind of strange number. It's a decimal with a 10 to the something. It's 8 times 10 to the what? 67. Huh. 8 times 10 to the 67. That means the actual answer is 8 followed by about 67 zeros. It's too big to show on the screen. 8 followed by 67 zeros there. So this is scientific notation. By the way, when you shuffle a deck of cards, the number of possible orderings of cards that you can have when you shuffle them is 52 factorial. It's this enormous number here. This number is larger than the number of atoms in the known universe. And what that means is that whenever you shuffle a deck of cards, go home and shuffle a deck of cards, get them in some order. When you shuffle a deck of cards and get them into a specific order, it's likely that the order of cards that you're getting is probably the first time in all history that order of playing cards has ever been given or will ever be given. There are so many possibilities there. Okay, so that's just a fun little factoid with all of this here. What is NCR? What is NCX here? What is this? This is combinations. If I ask the question, how many different ways could I pull 2 students out of this class? How many different ways could I pull 2 students out of this class?
You have to see how many students you have.
Yeah, in this class, we've got 6 students. So how many different ways could I pull 2 students out of this class? How many different 2-person groups could I pull out of this class here? Okay, so you two and you two and you two. What about you two?
One.
There's a lot of possibilities. 30 combinations? I think you're repeating some.
No, there's 5 people.
36?
No? Let's count them up here. What are the possible groups that we could have with Ta in them? Ta Sally, Ta.
6.
Yeah, 1, 2, 3, 4, 5. Okay, so those are the ones with Ta in them. Now let's go to Sally. We can do Sally and Ta, but we've already counted that one, haven't we? So Ta's out of the picture. So 6, 7, 8, 9. Now Sally and Ta are both out of the picture. Let's take a look at Boosie and Derek. That's 10, 11, 12, 13, 14. And then we finish up with Sierra and Noah. It's 15. 15. Do this for me. There are 6 people in this class. Type 6. Hit PRB. Choose 2 for NCR. Hit enter. And now type 2. Enter. So your screen should show 6 NCR2. And we get 15. Okay, that's what this is. And combinations, give you a chance to work with that a little bit more there.
So it's like we type 6, right?
Yep, type 6 and then choose NCR. It's 15. Yeah, 15 possible groups there.
Two since it's three.
Okay. So this is all about NCR is all about how many smaller groups, how many different smaller groups can we make out of a bigger group? Okay, that's really all it is. How many smaller groups can we make out of a bigger group? With that in mind, how many three-person groups could we make out of this class?
Three were right.
So you keep it right. How many three-person groups could I make? You three, but it could also be you and Ta
Oh,
and Derek, you and Ta and Sierra. There's a lot of them.
20.
Yeah. Let me see if I actually don't know. 6.
It's so NPR is the big groups or small,
It,
or that's
PR is something different. NPR is different.
okay.
That's National Public Radio.
It is. It's National Public Radio. So no, NCER is the one we're dealing with here. So yeah, three-person groups. No, I did get the right answer. There's 20 of them that you can make here. Okay. By the way, this is used sometimes in a lot of different situations. Like, for example, let's say that a company has been um, hiring for 7 different positions in their sales team. There were 500 applicants, 300 of which were white, 200 of which were black. And interestingly enough, there were no black people that made it into the job. Is it possible that happened by chance? Yes, it's possible that happened by chance. Is it possible that that's reflective of some biases that are going on? Yes. What this does, without giving any opinions as to how this should be handled, this gives us some numbers to be able to describe this. How many different 7-person groups could we make out of this 500? That's this many. How many of those only involve the ones who are white? I don't remember what the numbers were. So we could divide one by the other and find out what's the probability that that can happen purely by chance. If the probability is 20% or something, that's probably not indicative of anything. But if it's one in 1 in 3 million, we start to say maybe something's going on here. Okay, so it's not about quotas. This allows us to move beyond quotas because when it's just a few people being chosen, then you know you don't get an unusual probability one way or the other. It's only when there's a large number of people that you actually get a significant result with this whole thing. Yeah. So this allows us to take a look at that question more intelligently. Also, when you're choosing people for a jury. Okay, that same kind of thing can show up here. Anyway, here's how we calculate these binomial probabilities here. So you've got these 3 parts here, NCX, P to the X, Q to the N minus X. So here's how we do this here. A survey found that 1 out of 5 Americans says he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 of them have visited a doctor last month. You got to write down your 4 variables here, P, Q, N, X. Remember, P is probability of success here. What are we going to call success in this problem? It's a little subjective.
survey,
What's that?
survey. You can call it. Survey is the P.
When we survey them, there's 1 or 2 answers they might give. Going to the doctor in the past 10 years? Past month, yeah. So going to the doctor in the past month. And according to the first sentence, what's the probability that any given person has gone to the doctor in the past month? 1 out of 5. What's that as a decimal?
This is fraction.
What's that as a decimal?
Oh, and it's not.
Yeah. Ooh, we don't need our calculators for that. 1 and 5. What's that? So that's 1 and 4. What's a fifth of a dollar? 20 cents. Yeah. So 0.20. So if that's the probability of success, what's the probability of failure? Failure, in other words, tapping on somebody's shoulder and they haven't, yeah, exactly. Yeah, they haven't gone to the doctor. Okay, so these two are very related, aren't they? They're very close to each other. Okay. How many trials are we conducting? How many people are we tapping on the shoulder? 10. Okay. So we are tapping 10 people on the shoulder, and there's a bunch of different possibilities. It's possible that none of them went to the doctor. It's possible that one of them did, two of them did, three of them did, four of them did, five of them did, six of them did, seven of them did, eight of them did, nine of them, or maybe all 10 of them went to the doctor. Wouldn't that be cool? Where do you think the highest bar would be? It's about in that area, yeah. If it's a fifth, it's 1 out of every 5 of them that's gone to the doctor. Then when you're talking to 10 people, that's about 2 of them. So we'd expect that this bar, however tall it is, it's probably taller than any of the others here. And as we get into 5, 6, 7, 8, 9, these are probably getting really short over here. That's what we'd expect to see. So let's find out here. Find the probability that exactly 3, these are all values of x here, that exactly 3, oh, we're finding this one. Okay. It's probably going to be a little shorter than 2, but x is equal to 3 for this problem. So here is our formula. Be nice. There we go. It is n c x e to the x times q to the n minus x. Okay. Okay, so let's plug in our variables here. N is 10, x is 3. This is, oops, my bad. E is 0.2, and that's raised to the 3rd power. And Q is 0.8, and that's raised to the n minus x power. What's n minus x? 10 minus 3. Yeah, so tell me where.
The 3,
Um,
where's the P?
P is here, the 0.2.
Oh, I see.
Yeah.
Okay.
And then the x is 3, Q is 0.8, and n minus x is 10 minus 3, so that's 7. All right, so this is what we need to put into our calculators to find out. Okay, so this is how you find this stuff out here. I'm not sure what 10 choose 3 is. By the way, that's another way in which people say this. 10 choose 3. That's how mathematicians and statisticians would say it.
And
Yeah.
This is the 10 NCR 3 thing.
oh,
So we
That's a
find
lot
that
more.
out. By the way, if you're doing it in Desmos, just so you know, if you're doing this in Desmos, you type NCR and then in parentheses, gosh, this thing is just 10 comma 3. And by the way, this has to be a lowercase n, this has to be a capital C, this has to be a lowercase r. It's very, very picky. Okay, so yeah, if you're doing this in Desmos, you'll multiply this times 0.2 to the third power times 0.8 to the seventh power and see what you get
I
there.
don't see the CR in decimal.
The what?
The CR, like.
Oh, you have to type it.
You just type it in.
Okay.
Yeah.
See. Okay.
So yeah, see what you get.
Yes.
I saw.
0. Point, what'd you say?
0.01677728.
7? Did others get that too?
I don't know if I put that right.
Times something? That looks. You were totally right, except for the NCR part. So yeah, let me. There you go. Now you're right.
No, it's okay.
Okay. Um, so yeah, I'm seeing the Desmos result from Sally here. What'd you get? 0.2 something?
Yeah, 0.2013.
3.
0.2013.
2013. Okay. All right. So that is that value for just that one. Is when you put this into your spreadsheet, it's doing the exact same, it's doing the same calculation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, one for each one of these bars. Okay, so you do that a bunch of times to get this distribution here. Let's but that's the procedure here. So you've done it once. Let's try it one more time for a different problem here as well.
Is it, what was the answer? 201?
0.201.
20.
Okay. Here's another example. The problem's done for you here. A survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. Okay, so the probability that a given teenager is getting their spending money from a part-time job is 30%. Okay, so this is our P right here, which means Q is what? Q is 70%. Okay. If 5 teenagers are selected at random, what's that? What is this?
And
N, good. Find the probability that, ooh, at least 3. At least 3. So does 3, this is X, right? So what does it mean at least 3? If I want my salary to be at least $20,000 a year, and boy, do I want it to be more. Yeah, that's the minimum. So at least 3. So X could be equal to 3. What else could X be equal to? 4
any greater than
and 5. Yeah, so there's 3 possibilities here. What did we find here? We just found the probability that it's 3. We also have to find the probability that it's 4 and the probability that it's 5, and then we add all those things up. This thing does not like me today. So yeah, all of those things added together gives me that. So, and notice for each one of these, this is N, C, X. It's P to the X, Q to the N minus X. each time. So see if you agree with that. Are you seeing that same formula each time here? Here, everything's the same except x equals 4. This is still p. X is 4 now, so that's p to the x. This is q n minus x. So 5 minus
Why is
4
the numbers
is 1.
like low?
Which one?
The numbers, like they're lower.
You'll have to show me.
Get the 5, 4.
The powers.
Oh, these right
Yeah,
here?
Yeah.
Yeah, these are subscripts right in here. It's just how we say it. Yeah. So, yeah, the way we describe this is we just write it that way. So it means absolutely nothing except that's the way we show it. Incidentally, there's another way in which you see this being shown. If you just want to be confused even more, sometimes they'll show it this way. It looks like a fraction, except there's no fraction bar and there's always parentheses around it. That's just a little piece of trivia there. Okay. Public opinion reported that 5% of Americans are afraid of being alone in the house at night.
Like me, just be afraid to be alone.
That's right. There you go. I like that. There you go. Probably a higher percentage of that. If a random sample of 20 Americans is selected, find these probabilities by using the binomial table. Okay. So we've got our P, Q, N, and X. They've given us 3 of those 4 things. What have they given us? 5% is what? Might be a little easier to tell me what 20 is first here. What's 20?
Total chance.
Yeah, number of trials. So what's each trial? What's a trial in this case here? Yeah, so what's happening with each trial?
They're testing.
They're testing what?
They're 5%.
Well, but what are they doing with each trial? If a random sample of 20 Americans is selected, what are they doing with those 20 Americans?
Separate, like they're selecting only 5% of.
Ooh. Read this with the math brain turned off. Your math brain is now confusing you. Read this like you're in a social studies class or a history class or something. What's going on with this problem? Ooh. What do you think, Noah? You've been kind of quiet.
Oh,
I've just been reading it through my head a few times today.
Okay.
well, 5% is like the whole
They report
American
public-
population, and then
Yeah.
they're gonna from the a population, they're gonna select a sample of 20 Americans.
Yeah. So now you're just walking downtown Greeley and you're tapping 20 people on the shoulder and saying, "Are you afraid of being at the house with crazy now?" I didn't intend for that to happen, but yeah, asking if they're afraid of being alone in the house at night. That's right, exactly. That's right. I'm just having a policeman's knee in my back now. So that's like the start of a horror movie right there. So yeah, so
John Wick.
exactly. So when we're tapping the person on the shoulder and asking them the creepy question, what's P? The probability of what? Yeah, success is what in this case?
Them actually telling you they're scared of
That's exactly, yeah. So a person's afraid. Yeah, what's the probability they're going to tell you that they're afraid? According to this study here, 5%. So that's 0.05. So what's the probability they're going to say, no, get away from me. I'm not afraid. 95.
No, but boy.
That's right, exactly. We haven't been told yet what X is. Oh, but now we have. What's the probability that 5 of these people are going to say, yes, I'm afraid. Okay, so that's NCX here. So 20C5 times. You might really find that Desmos is the best way to go here when it comes to putting in these formulas here. Let's see, N minus X. What's N minus X for this problem here? N minus
Four.
X. 20 minus 5, which
Oh,
is
15.
15. Yeah. So let's see what we get there.
For the Q, is that a 0.25?
9.5.
I was like. I confused.
That would confuse me if I thought it was 2.5. So that's 9.5. Okay. What do we find?
Point 002.
0.002. Which as a percentage is what?
Point 02.
0.2. So less than 1%, isn't it? Yeah. 0.2%. So what? Is that likely? No. Why is it unlikely?
Because you can't afford to pay rent by yourself, so you're more likely to.
Well, yeah, that's right. Yeah.
Colorado.
Remember, only 5% of the population says they're afraid of being alone in the house at night. And you talk to 20 people and 5 of them are saying that they are. Does that seem likely?
It's
No.
not. It's not a big portion of the
Yeah.
population.
Yeah. The peak of this should be around 1 or so, because 5% is 1 in 20. Okay, so this is kind of high. So that's the idea here. I just wanted to let you see that and just know that your binomial spreadsheet will calculate this for you. But if, in case you haven't created that, by the time we take the test, you'll have this way of calculating those things as well. If you have questions on project 3, please feel free to ask it because that's due tonight, right? Yeah. So, okay.
So I get a Multnomah County Sheriff or a really PD officer asking me, if I see a guy going around town asking if you're afraid of the house at night.
So